Well, thank you for doing this problem. This is one of the problems coming in the last exam, so this is very well worth your time to do. So I see this using the sigma notation and some other things I noticed that I'm going to infinity. So this tells me that this is an infinite geometric series. And because they're telling me that it does have a sum, that tells me that the common ratio is less than 1. That means it's going to decay. Um, think about exponential decay. So I don't really know. I know it's a geometric series because they're telling me that. And if it's an infinite arithmetic series, that doesn't have a limit because that goes to infinity or negative infinity. So what we're going to do is do a couple things. First off, we've got to remember that to find the sum of an infinite series, a geometric series, that's the first term over 1 minus r. So I got to figure out what the first term is. Well, if n equals 1, 8x to the 9 times 1 is 8x to the 9th. The second term, if n equals 2, that's going to be 8x to the 9 times 2, or 8x to the 18th. And I could keep going, but since we're just looking for the common ratio, let's take the second term and divide it by the first term. And the 8's cancel off, and when we're dividing like bases, we subtract the exponents. So r equals x to the 9th power. So I know I can go back and set up my infinite sequence, the infinite series. So 25, they gave us that, right, is equal to the first term, which is 8x to the 9th, over 1 minus the common ratio, which is x to the 9th. So to solve this equation, it's really just a proportion. I'll do the cross products. So 25 times 1 minus x to the 9th equals 8x to the 9th. I'll distribute through the 25. I got to get the x's on the same side of the equation, so I'll add 25x to the 9th to both sides in this equation. What's that going to be? 33x to the 9th. Then I need to solve for x, so I'm going to divide both sides of this equation by 33. Oh, here, I'll write it out. I didn't want to do that, but I will. So 25 over 33, and that doesn't simplify at all, equals x to the 9th. So since I'm solving for x, I'm going to take the 9th root of this, and that is all that MyOpenMath is looking for. You can type in 9th root of x of 25 over 33, and that will give you the right answer.